welcome again. And my name is Kendi Ladipo, and I'll be talking about fire drills for software engineering teams. So a little bit about me. I work as a software engineer at Microsoft currently, and the things I do at work involve building web services. I'm a software developer, so I work on the web. I also do some infrastructure engineering. You find me working on cloud infrastructure setup, DevOps and all. And I am also a team lead. So I'm working with my team to ensure that we are doing the right things and we are being productive while at it. So yeah, on to the next slide. And so like I said, we'll be talking about fire drills for software development teams. If you already have you're working in a team or you have products running in production, then this topic is for you. Or if you are looking to go into the field of people who site reliability engineering, this will also come in handy for you as well. So how did I come about this topic? I was casually browsing through Twitter and I came across this tweet from a senior colleague who said that the best systems are used constantly, and if you've never tested your failover or backup system, then the chances are low that the system will work well on the first try. And it got me thinking, because I don't get to see this kind of tweets every day. Like, people don't really talk about backup systems and the reliability of backup systems. So I looked up fire drills and I didn't really see much articles. So I started writing one, and I'm not proud to say that I have not published the article. But when I got the chance to do this talk, I decided that I would talk about this, and finally I will publish my article. So I replied, I said, I don't think we talk enough about fire drills for software development teams. And today, let's talk about fire drills for software development teams. So a bit of a disclaimer here. This talk is, we are going to talk about fire drills in general, and we are going to look at industry-specific examples, relevant examples from the industry, that relates to the talk. But I'm not here today to promote any company's culture or fire drill processes or incident response processes. I'm just going to talk about it in general. So that said, what are fire drills? In big apartment complexes and office buildings, you'll see that usually they have many occupants, usually occupying multiple floors as well. So usually they conduct fire drills, which is an exercise meant to get the occupants of the building to practice adherence to safety, to established safety protocols and procedures. So what happens is that once the alarm goes off, the occupants are expected to start to follow the previously set emergency procedures for that building. When the alarm goes off, they can decide to look for the nearest exit and go for it. And the aim is to practice so that the occupants will know how to respond when an actual emergency thing happens in the building. And the success is measured by how well those occupants conform to the safety principles that have been set. So usually they check for things like, okay, how quickly were people able to evacuate the building, the evacuation time, or how well did they adhere to these procedures. They check things for head count. 30 people said they were coming into the office this morning. After the fire drill, were we able to get 30 people out of the building? And also things like discharge of roles. If, for example, usually have things like, they can say for this department, this is the person who is going to be in charge. And the job of that person is to ensure that everybody evacuates to safety. So the success is measured by how well that person discharges their duty. Were they able to account for everybody? Were they able to see that everybody gets to safety? They will say, don't carry your bag, just leave for the exit. I remember one of these exercises that was conducted one day. I was having a late lunch, I think, and the Nigerian thing where you can just eat your food first and leave the protein till the end of the food. So I had finished the rice, and once I was about to start eating the chicken, that's when the alarm went off. I had forgotten that there would be a drill, so I just left the chicken. I did not eat. So next time, try to eat your meat first. That's the lesson there. But this is not the drill we want to talk about today. So the thing with the topic is that Many of the concepts in computer science or tech, in our industry generally, are named after everyday objects and phenomena, and fire drill is not an exception. So another thing that we use fire drill to describe in this industry is a project management anti-pattern where you see teams are scrambling to do so much in a short period of time. Like everybody is working under intense pressure, there is time constraints to be met, and a lot of goals to be met. So you see things, people say things like, oh, my team is running in a fire drill approach. But this is not the drill that I also want to talk about today. So for the purpose of this lecture, fire drill is simulation in the sense that the team who is conducting the drill, they try to simulate a real-life failure of their system. For example, things like, okay, our storage is down, our backup is not working, that kind of thing. Our main storage is down, right? And then the second step is recovery. After simulating a failure, you try to recover from that failure, which could be maybe trying to like swap out a live storage for a backup while the main storage kind of heals from the failure. And fire drills is meant to prepare a team for incident response. It makes them prepare well so that when the actual incident strikes, they know what to do. They are already familiar with the processes of responding to incidents. So using our failure scenario, you can quickly switch to a backup. And in that case, number one, you can validate that the backup system that we have actually works. Because if nobody is using the backup, by the time we have an actual failure, we won't know that the backup has not been backing up for some time. Also, you are sure that your engineers know what to do when an actual storage fails in real life. So basically, the drill is to prepare the incident, the team for the next incident. And incidents happen all the time. We're going to talk about that. And then it helps to improve the team's incident response processes. And most importantly, it helps the team to make projections. For example, after using our same storage backup example, the team can make projections like the average time it takes to switch from a main system to the backup system. And after doing this multiple times, they can say, oh, it takes an average of 15 minutes to switch. And then they can be able to project things like the lag between the volume of data in the main system and the backup. For example, it's possible that your backup synchronizes after every 20 minutes. So maybe by the time we switch, we won't be able to recover data from 20 minutes ago. And it helps the team to better prepare. For example, they can say things like, okay, what are we going to do in order to recover the data from 20 minutes? Do we need another level of replication somewhere between the main and the backup? Or should we just discard this as a total data loss? And it just helps the team to prepare for this. So why are we even having these conversations? Why should teams go through the stress of running fire drills and all? Number one, systems fail. Like every software systems fail. Incidents happen all the time. Our favorite social network can go down. Our favorite cloud service provider can go down while taking their sister services along with them. So systems fail, and it could be internal or external. It could be someone has written a bug or human error somehow takes down the system, or it could be external. Maybe the hosting provider is the one that is failing, or something that is external to the system, but the system depends on it when the dependencies fail. So because systems fail, you should have a plan for responding to incidents when they happen. And it's not just enough to have the plan, but we should prepare and by testing that the plan would work. So basically, that is fire drills for you. And systems failing is not an oddity. It's something that happens all the time around us. From history, in 2012, a cloud service provider, they had a failure in the region because the backup generator. So when we are saying backup, we don't necessarily mean the data backup or the backup for storage. It could be a physical backup, like a power backup, which is a generator. In this case, it was their generator that failed and they tested it just 6 weeks earlier. But when there was an actual power outage, the actual generators failed to kick in, and the services were taken down because of that. Also in 2009, a powerful world government lost 84,000 prisoner records, and there was no backup for this. So in this case, it was an absence of backup. And in 2019, one of the powerful cloud service providers also experienced an outage because, so a normal day for the engineer on call, but there was something that necessitated them running a command that they used to run, right? And the engineer mistakenly went to input one of the inputs into the command incorrectly. So this caused the system to start removing many of their servers, like in quick successions. So it took down a lot of servers, and it now because many servers had been taken down, that necessitated a full system restart. But this process is trusted and tested. It's trusted because they know that this is what we are supposed to do. But they had not run a full system restart ever. They had never run a full system restart. So that didn't go so well, and that kind of like elongated the recovery time for the incident. So the message is that an untested backup or recovery plan has a very low chance of working flawlessly when you need it. And when we say this, it's a bold statement to make. So without data, it will just be pure speculations. In 2019, IDC is International Data Corporation, and they pride themselves as having like real market data and analytics. So they conducted a survey that had 500 respondents across many industries and tech. And then from this survey, 38% of the respondents said that only about 38% of them have a plan to recover from incidents. And out of the 38%, out of this, only 23% of them said, we just have this plan, we never test it. We just know that we have a disaster recovery plan. It is not tested. And then 29% of them say we have one, we test it, but we just test it once a year. And more data, 44% of the respondents said they usually have backup reliability problems. 91% of them reported having a tech-related service disruption in the past 2 years, and 18% of these were severe. Also, 26% of them said that they experienced permanent loss of customer data due to backup failure. So when we say that, systems or companies or teams suffering from system failures or backup failures or incident response procedure, it is more common than we think. So how do you plan for a fire drill? When we say, okay, the team should conduct a fire drill, what are the things that we need to do in order to plan? The first thing is to document common incidents and their response procedures. So as you are writing the software, you are hosting it, you are the one who knows your system. Write down the ways in which the systems can fail. What you find is that usually for certain systems, it is just a few people who know the system end to end. So if something happens, we have to call somebody to say, come and carry your wahala, But in order to facilitate knowledge sharing, document all the common incidents and their failure procedures. Like on my team, we have a document where we write this. We call it a troubleshooting guide, and it is just meant to help the engineer on call to know what to do if we are experiencing maybe an incident happens. And the next thing is to organize training. It's not just enough to document this. You need to train the engineers so they are better equipped to know what to do when your incidents happen. Then identify dependencies in the system. You are using a cloud service provider, write it down, let people know. You are using a certain data storage or backup system, let people know. Basically, it is doing an inventory of all the dependencies that the system has. Also set the scope. The goal of the fire drill is not to take down the entire system. So you want to test it like smaller subsystems, not just like the entire system. And this will help you to minimize the blast radius, because if something does not go well, you don't take down your entire system. You're only testing a particular subsystem. And keep it simple. Use everyday languages, simple English that people will understand. Don't let people go and carry a dictionary to try to understand what you are saying, because usually you see that people are already tense if an incident happens. So if you are now putting big English in the documents, it won't be nice. So in a fire drill plan, what are the things that should be in there? The first one is the communication structure, like the plan to notify stakeholders. Who are the people that we need to tell if we are conducting a fire drill? And then you need to set objectives for the recovery time and the recovery point. Recovery time objective means that I want to run a fire drill on a particular subsystem, and I'm expected to have recovered in 15 minutes. Like from the time I take the system down or do something to the time I recover should be 15 minutes. That is recovery time objective. Recovery point objective is how much of the recovery I'm expected to have done in X minutes of time. So those two kind of go together. And the next is role and responsibility assignment. So on the team, you have people like incident commander who is responsible for, who is going to be like the general, like who controls everybody, not control, but who is going to be in charge of the incident. You can have someone who is going to be in charge of communications. You can have someone who is going to be in charge of, who is going to be like the technical expert on that incident. So assign roles and responsibilities so people know what to do. And then response procedures, like if you are running a fire drill on a particular subsystem, have plans for what we want to do in order to recover from that thing. So have troubleshooting guide, let people know the commands to run for those kind of failures. And then set a scope, minimize the blast radius, don't take everything down at once. So scope for parts of the system. And then most importantly, have a failback procedure. So if you are running a fire drill, it is important that even when the drill is not going well, we can always go back to where we were before. So not that the drill will take us to a point of no return. So now that we have identified things that should be in a fire drill plan and how to build up to a fire drill plan, what are the things that a team can embed into their system to make them better prepare for incidents? Number one is good code. And it sounds simple and trivial, but it's very, very important. While write code that is maintainable and encourage a culture of writing good code on the team. Dependency injection is one commonly used example. You are writing an application that needs a payment provider. Don't do new pay stack provider and move on. No. Use an payment provider and have a provider that does pay stack, have a provider that does Flutterwave, so that if you have to switch or swap payment providers, it is easy to do that with dependency injection. Your system would not be tightly coupled together. And the next one is to have automated deployment. Like, let it be clear the path that your code uses to go from pull request to production. Is it that when people just merge, the thing is headed for prod, or anybody can just deploy to production from their box? Have standard pipelines and procedures to do this. It usually helps. Next one is have versioning and rollback strategy. If someone has rolled out an erroneous or buggy code, how easy is it to like rerun a previously working version of the system? And that's where versioning comes in and rollback. Also, we have infrastructure as code, which is you codifying the process of setting up and configuring your infrastructure. How easy is it for you to set up parts of your system or all of the system? Like, can you set up a copy of your entire infrastructure again if you lose it all? Also have multiple environments, like isolate environments, dev environments, staging and prod. Nobody does rough play in production, do all the testing and everything in dev. Then automated test, as you're writing tests, unit testing helps. So we're able to catch all the bugs earlier, end-to-end testing in the pipeline and all of that. And next, documentation, quite important. Like, we, as engineers, we make a lot of assumptions. We assume that some things are trivial. People would know. But context is very important in everything. We assume people know something, but if they are missing the context, they really don't know why we made certain decisions or where some certain things live. So you want to document all the things. Don't assume that people would know. Also, don't keep knowledge resident with one or two engineers on the team. They might not be available when an incident happens. Have a troubleshooting guide, which is to help whoever is actively monitoring, running the drill, or even in the case of an incident, whoever is handling the incident, they know where to go and look, something that will guide them. And also, monitoring and alerts usually helps teams to, as the name implies, monitor the system. So, and how this works is, Usually what you are listening for is you are setting up monitors to listen for certain events or metrics on the system, and there are certain thresholds. For example, you want to say, okay, my system must not return 500, which is internal server error, more than 5 times in 60 minutes or something. And by the time you do this and there is a percentage, maybe you set that is the threshold. And if anything happens and your system goes below this threshold, then an alert should be triggered so that everything will go through the normal alert process. So if you are running a fire drill tool, you should do it in such a way that whatever you do triggers the alert, and that's usually the way that the incident will come anyway. So I remember when my team was setting up our alerts for a particular service, I remember that the engineers on call were having a field day because like the alerts were just going off non-stop. And he said a lot because it indicated some things were not quite as all right, and we got to work, started fixing the bugs, making improvement and all. We also saw that some alerts are just too sensitive, like they were false alarms, and those ones we tried to like make them less sensitive, and and engineers, it made life easier for engineers on call, and as a result we also got a better system. So after the fire drill, you have run the fire drill exercise or an incident has happened actually. I'm saying these two together because a fire drill is just like the simulation of the actual incident. An actual incident might also have happened. So whether you have run a fire drill or you have had a system outage or any incident, conduct postmortem. And postmortem is something that is done after we have settled the incident. It's usually the team coming together to say, okay, what actually happened, what triggered it, what caused it, right? What did we do? What steps did we take in order to address this thing? And the key word there is it should be blameless. Even if it was an human error, someone did something or wrote a bug or they didn't do something that they were supposed to do. The point is not to like point fingers and assign blame. By doing that, you are cultivating a culture of mistrust, and engineers will not feel like they are in an environment where they can do their better work. People tend to be conservative. They don't want to like explore and innovate. So it should be blameless. And also update the incident response processes. If anybody had to do something that was not in the document, it's usually a good time to now go back, to go and add that thing that we had to do outside of the incident response process. And also, it's not a one-time effort. So you have to like practice, and do it multiple times. And then continuously revise the plan as the systems evolve. Systems grow, we add things, we make improvements, we remove, we add features as well. So as the system evolves, the incident response plan should also evolve with the system. Now, we have talked about planning for a fire drill and what are the things that you can do to make the fire drill successful or to have a better system generally. We've also talked about what to do after the fire drill. But in this section, I will be talking about how you can actually build the system, the resiliency into the system. Like, make the thing that pokes the system part of the system. And that takes us into the field of chaos engineering. So chaos engineering is an entire discipline on its own, right? And it involves you experimenting on ways that will break the system in order to build confidence in the system's ability to withstand trouble or turbulence in production. So, and it involves you starting from a steady state. Like for every system, there's usually a steady state, and the steady state is like 200 OK, where nothing is happening, right? So that is the steady state. And from the steady state, you now go to a place where you introduce variables that reflect a real-world failure into the system. So it could be a server crash, or maybe a hard drive that is not working well, or if it's like a microservices architecture, you can add a lag between the response time, add some latency between the time that the dependent system uses to respond to the one, and see how your service reacts to that. You can simulate a CPU maxing out scenario as well. How does your system undo this? So many companies do chaos engineering, and Netflix has a tool. The tool is called Chaos Monkey. It is an open source project, is on GitHub, and what Chaos Monkey does is that it just, on the Netflix network, it terminates virtual machine instances randomly. So you might be streaming, let's say, King of Boys, and Chaos Monkey strikes. So what happens? Does it freeze? Or does the system buffer in order so that you don't even notice? Does your screen go blank? And these are like things that Netflix must have observed in order to like build a better system. So you're building the system to withstand chaos. And Google also runs DIRT. DIRT is disaster recovery testing, which is a periodic exercise at Google where they used to, like, just rigorously test parts of their system, introduce some chaos into it, and see how they are able to respond. Also on my team at Microsoft, sometimes I just get random alerts of services saying we are running a drill. So usually teams just run drills in order to test the reliability of their system. And there are commercial offerings as well that do failure as a service or chaos as a service offerings. There is Azure Chaos Studio, there is Gremlin, there is an AWS offering as well that is commercial. So if you're interested, you can check them out. So the key message here is that you should test your incident response processes as a company, and don't be left hanging when the actual incident strikes. Like they say, prevention is better than cure. You can I added some links here for further reading and all. And thank you for listening. Does anybody have any questions for me? Questions. Am I free to go? I'm tensed now that there are no questions. Is someone? Okay.
Channel.
Thank you for the hello.
I can hear you.
Okay, so my question is, does your system architecture, your software architecture, does it have to do with, does it have a connection with the fire? If you have a very robust, like an entire system architecture, or you have a 3-tier, so like Yoruba people used to say, the bigger your head, does it matter with the headache too? Is it going to be, do you get my logic, my point? Yeah.
That's a very good question. So yes, the big head, we cannot divide the head, but we use plate of food to like make my example. So what we are going to do is to divide it into smaller subsystems. Like no matter how big the system is, it just means the system has more and more components. By the time we look at it from like a point of view that compartmentalizes the things that make up the system. So what we are going to do is we'll be looking at not testing the system as a whole, but like introducing variables into parts of the system that can test. So what you are doing is like stress testing, maybe database failure, for example, and if it's like a multi-tier system, like you said, if you are doing database test, for example, now the front end layer should not fail this, right? It should be the back end that actually directly is talking to the database. So I don't want to we should not be saying something that reflects this thing on the front end. It is the back end that we are going to engineer in such a way that it's able to undo that. Does anybody else have a question? Okay, someone has a question. One last question. Oh, so we won't be able to take questions, but I'll be happy to talk to you after the call. Thanks so much for listening. Have a good day first.